what to do, and occasionally they listen.
We've created a toolpath, essentially G-code, and we've sent it to the robot.
That just sounds so cool, it's really interesting, and I just jumped straight in.
Lot of great researchers where I can share my ideas, they can give me feedback.
Everybody that's here understands the importance of inclusion and inviting people in.
You have an idea of how it should work, but it doesn't always work like that, and it can be for a number of reasons.
You're adding a grain of sand of knowledge to the beach of knowledge that is always there.
There's an entire world out there that we can't see, and I personally find that fascinating.
My research is specifically on automating assembly systems. So I'm looking at determining the orientation of components for robotic grasping applications. The idea is you have a component, like a crankcase of an engine, coming on a conveyor belt in any orientation. You can get a snapshot of it from a camera located above. From that we extract the edges and we get a toolpath. That means that if the part was to change geometry or orientation anywhere along that conveyor belt, we don't need to change the program for the robot. It does that automatically. It's going to take that image and it's going to run that toolpath. What we have it doing is something a little bit more interactive. So we have it, you take someone's photo and it'll take that photo and it'll turn it into G-code and it'll draw the person.
This one here is the UR3. It's all to do with the gripper, and there's a few tools more flexible in the human hand. You can pick up just about anything with it. So in this case, if it detects a collision, the hand's going to open. So I can just fist bump it. And then I can place something in it, and if I give it a firm sort of whack in there, it detects it, closes, and off it goes.
My work is computationally based, and what I'm researching at the minute is astrocyte motility, which basically is involved in memory formation within the brain. It's a particular type of cell. So I'm looking to assess if there's a possible way that astrocytes are involved in diseases such as Alzheimer's and dementia.
So I'm looking at using virtual reality, augmented reality and mixed reality. My work has been used for different populations like a stroke patient. People will be able to put on these headsets and play games while doing the physiotherapy exercises. Patients take the headsets home and they have an interface with different wee games they can choose from. Using the fine motor skills in their hands, it motivates people to stick with physiotherapy.
I'm a PhD and research associate in system simulation. So in terms of my research, the main thing that I was interested in was working out, can we detect autism in young people based on how they walk? And then the other thing is, can we capture that with just a RGB camera? The way we currently detect autism in young people is through observation and questionnaires. And so the idea of using gait analysis as an alternative is it's a bit more objective.
My research is focused on computational material science. I'm looking at powders that are used in powder-based additive manufacturing processes, and I'm trying to characterize the powder particles to help reduce defects in the produced parts. These powders would be used within automotive parts for cars and so on, parts for aeroplanes. At the moment I'm working with titanium 6-4, specifically grade 23, which is known as a biomedical grade, so that can be used in 3D printing, knee replacements or hip replacements as well. So there's such a wide variety of applications and areas in which this work can be used.
So a lot of my work involves trying to enhance reliability and fault tolerance of electronics through the use of AI. So we have embedded processors running inside chips, and when these chips are deployed, neural networks or the AI that we develop sits alongside it and can continuously monitor it. So in your brain you have neural networks consisting of neurons which communicate with each other, and we actually take inspiration from that and apply that to electronics, or we try and develop models that run off the same principle.
In this lab we have MEG machine or magnetoencephalographic machine. This machine is actually measuring the magnetic activity of our brain when we do the task, and then we use that brain activity to control a robotic arm that can assist stroke patients. So this device is basically focused on giving them neuroreplasticity or relearning of that particular activity.
think the community, especially at McGee, everyone in this lab knows each other and we all kind of have similar backgrounds.
I think the campus is quite beautiful, it's quite a cool place.
I think the fact that it's a smaller campus is a good thing for it because you know the people in your environment.
I have a 5-10 minute break to go for a coffee. There's a few coffee places we can go to and we're walking up the stairs and you're looking out over the river and the bridge.
Everyone's so supportive. We all talk when it's just like a big family. We all see each other struggling and getting stressed out of our work, but then also we see everyone else's successes and it's just amazing to see.
Because if I get stuck in a rut, being able to turn around and go and chat to some of these guys, it can really pull you out of that.
And of course, most important thing as well, really good burritos about 4 or 5 minute walk that way. So if you're looking for something for lunch, that's the recommendation.
You are actually impacting someone's life to bring them back to their normal life from a complete locked-in paralysis condition.
It's improving the world in a way that's semi-personal to me. I have family members that have autism and I know the impact it had on not only them but the family members.
It's incredible to think about that something I could do can then be used by other people to have a positive impact on them. It just sparks the joy of it all over again.
When I started, I had no idea how to do any of this. Computer vision, move the robots, any of that stuff. As soon as you show someone something like, you know, this robotic arm or the ones we have in engineering with welders, I mean, how can you say no to that?
Johnny 5 from Short Circuit, that was my favourite film as a kid. I had it on VHS tape and I wore it out. And so when the opportunity came up to actually, you know, do the real thing, yeah, I kind of had to, yeah. I couldn't turn that down.
It takes perseverance to get through it, but it takes the enthusiasm and the love of the job itself. So if it's something that you're really interested and you really want to make a difference, especially to the future, it's a good opportunity for them.
What was the word we were doing? Aspire to competence? That's what we said. We aspire to be competent, at least.